Hello everybody. Today I'll be doing an experiment to determine the speed, the amperage, the efficiency, and the range of my trolling motor. This is not supposed to be the be-all, end-all for every boat ever. This is just to give you one point of reference that I'm getting today for if you have a small pontoon boat like mine, or if you have a John boat, or if you have even a kayak. This is just to give you one point of reference so you can get an idea of what's going on. So let me show you what we're working with here. Okay, so let me show you my setup. My boat is a Bass Pro Shops Pond Prowler 10. My trolling motor is a Newport Vessels 55-pound trolling motor, and it is equipped with an Autoboat Smart Head, as you can see. My battery is a Golden Mate Orion 1000 100 amp hour lithium battery. Okay, so what I'm going to be doing today is testing out each of the 10 speed settings that this motor comes with. I'll be measuring the speed using a GPS and the amperage using the battery's internal measurement system. Let's get started. I'm starting us off at 15% throttle. Apparently we're going at 0.2 miles per hour according to my GPS, but we aren't even keeping up with the wind. The wind is blowing me sideways. Let's check battery amperage. Battery amperage is 0.77 amps, as you can see. Okay, so now I'm going to turn us up to 20% throttle. You can see this is my Autoboat screen. At the top in the middle it says we're at 20% throttle. Now let's check speed. Yeah, I don't know how accurate this is when we're moving super slowly. It's still saying 0.2, so I'll just go with that. And how much amperage are we pulling? 1.28 amps. Okay, the slow speeds are really not going to give us much data, but I want to do them anyway. So turn us up to 30% throttle. Okay, so the slower speeds are too slow to get any useful data on speed, but this is what 30% throttle looks like. And keep in mind, the wind is blowing directly toward me, so it might not be as fast as it looks. But speed is 1.2 miles per hour, according to my GPS. Let's check amperage. Amperage is 2.82 amps at 30% throttle. So let's try 40%. %, throttle, 1.8 miles per hour. And the speed is, the current is 5.4 amps. Okay, so let's try 50. $50 miles per hour, imagine that. 50% throttle, 2.3 miles per hour. And 8.74 amps. Let's try 60. .6 miles per hour and 13.53 amps. Okay, let's try 70. .70% throttle. We're getting 3.1 miles per hour and a current of 19.1 amps. Let's try 80. 80% throttle. Give it a minute. 80% throttle, 3.5 miles per hour, and 25.7 amps. Let's try 90. .8 miles per hour. And 32.8 amps. Let's crank it all the way up to 100. So I can just barely hit 4 miles per hour at 100% throttle. And my amperage, 39.75 amps. Before I go any further, I'd like to just show a table of all the results that we just got. So feel free to pause the video, take a screenshot, write this down, whatever you want to do. Okay, so now I'll show you what these speeds look like at the stern end of the boat. This is 15% throttle, and keep in mind there is a decent amount of wind, so don't let the waves deceive you. We're not going that fast. This is 20% throttle. This is 30% throttle. You can see my boat's starting to make a little bit of a wake. This is 40% throttle. We're picking it up a bit now. 50% throttle. Going faster. 60% throttle. Really making some bubbles now. 70% throttle. 80% throttle. 90. Finally, this is full throttle. You can see the rooster tail coming off the back of my boat right now. Not really, but that would be funny. But this is what 100% throttle looks like. This is the graph that I just made of throttle percentage versus speed. As you can see, it's an almost perfect linear relationship, and that makes sense, because I'm guessing what the throttle percentage actually refers to is percentage of maximum RPM, so it makes total sense to me that it would just be a linear line like this. So let's take a look at throttle percentage versus amperage. This is a graph of throttle percentage versus amperage, and as you can see, it's an almost perfect quadratic relationship, and this also makes sense. Drag force is a function of the velocity squared, so if you double the speed or the velocity, you quadruple the drag force, and so you would need 4 times as much energy, 4 times as much amperage to overcome it, and to move the boat forward. One more thing I'd like to show is a table of maximum running time and maximum range at each throttle percentage. As you can see, if you keep it at 30% throttle, you can run for 35.5 hours and make it 42 miles, which is pretty insane. If you crank it all the way up, though, you can only run for 2.5 hours. However, you can still make it 10 miles. So I hope my one rudimentary experiment has given you some helpful information. Like I said, this is not intended to be the be-all, end-all. This is just a piece of useful information for if you have a small boat like mine and you're curious what your range is, what your efficiency is, what your speed is. I hope I've been able to at least help answer those questions. So have a nice day. Thanks for watching.